on the left.
For linear transformations, what we're doing is we're saying, okay, if you can put 2 into x for f of x and get 7, can you put a vector into a function and get a value? Another vector. And the answer to that is yes, you can. You can take vectors and transform them using a function and get something very different. I kind of like the example, and then I'll go back and talk about what they're doing here. Let's say you have v equal to vector 1, 3, and you have this wonderful little transformation formula that says y over x plus y, x minus y. So in other words, this is my x and this is my y. Okay? Now, if we put this x and this y into this transforming vector, you're going to get 3, 1 plus 3, and 1 minus 3. And that's what we call a transformed vector. Can you see any reason why we'd want to do something like this? Yeah.
So you can do like weird stuff with like I and argument points.
This is building into like tensors. So if you're designing like a building and you're going to expand something, you can expand the dimension or the size of it. A lot of weather patterns are done with matrix algebra and tensors. Anytime that you're doing like shears and any kind of enlargement or shrink or changes, you can control all of the dimensions with the functions within the vector. It's pretty powerful math. Think of it this way. It's just a bunch of functions. It's almost like a piecewise function in a vector. This controls the x, this controls the y direction, and the z. Yes?
The input vector can also be a function, and it would output a function of that function.
Oops. Funny you should say that. It's exactly what we're going to do next. So when you look at a linear transformation, being able to do it, this is going to look very familiar to you. You have to be able to add it and scale or multiply it. Sound familiar? What did we do that with? Subspace. And we'll do it with subgroups in the spring. But what's nice is you don't have to learn new stuff. It all connects, so you don't have to. So just real quick, this is subtle, but completely makes sense. If you're going T of u plus v, then that's the same as taking the individual transformations of each vector and add them together. This is not automatic, and we're going to see a lot of exceptions to it. This one isn't as affecting as 1, but it is the idea that if you go T of 3x, you get the same as k times T of x, or T of u. Alright, so let's see how we would actually prove this. This is the transformation from xy to y, x plus y, x minus y. What's interesting about this particular transformation? Anything? 2 to 3 dimensions. So these are transformations that are much more revelatory than just getting a little bigger or getting a little smaller. You can go into other dimensions. You can pop out of dimensions and do different things. So we're looking at a relationship. So we're going to prove that this is or is not a linear transformation. So you have your u is x1, y1, b is x2, y2, and we're going to show that T of u plus v is going to be the separate of those two, T of u plus T of v. Think of it as distributing that T into u and v. So I go u plus v, which is x1 plus x2. Here we go. And then we're going to do y1 plus y2. That's the sum of those y's. And then where did this come from? Yeah, that's the transformation. That's this thing here. So when we put x plus 1 plus x2, it doesn't appear in the top because we only have y. So it's y1 plus y2. And then when we put the x, maybe it would help if we highlight these here. So you can kind of see what's going on, if you don't already. That's what they're doing. And then we can think of these, because they're added, we can split of y1 over x1 plus y1, x1 minus y1. Remember, this is distributed through. So this is a minus y1 minus y2. Do you agree with that? So then when I get x1 minus y1, I can have x2 minus y2 here. The pluses are no problem. So since I have it this way, this is t of x1, y1. This is t of x2, y2, which means we have t of u plus t of v. You have a problem where you're going to do that. Do you think you can do it?
Yeah.
I think so. It's not too bad. With the k, don't worry about v. Don't worry about vector v. Just worry about u. It's easy for a teenager, right? Just kidding, just kidding. It's easy for adults too. Easy for adults. So t of k x1, k y1, and then when you put these in, just like before, you've got the top one going here, and the bottom one going there. And that is, we can pull out a k out of everything, and so it's k times that algebraically, and so then it's just k times t of u. So we've got the addition and the scalar multiplication, ta-da. So what if you want to disprove a transformation? Well, what you have to do is to come up with an example that doesn't work. So we're going to do one, and that's the proof. You find one, this is what science does. Science disproves. They never prove anything. Did you know that? I hope they told you that. When somebody says we're going to prove it with science, that doesn't make any sense. Because science can never prove. Why can't science prove something? You can't test every possible variable in every situation. But if you find one thing that disproves it, then you can disprove things. So, when they're trying to disprove relativity, after 103 years, I think relativity came out in 1905, 103 years, they haven't been able to disprove it. Has that proven relativity? No, but it's relatively, yeah. So we're going to just do a counterexample. This is a proof technique that I love because it's so easy. And you don't have to do a bunch of wordy steps. All you have to do is find a counterexample. So we're going to let u equal to 1, 1, v equal to 2, 3. But that's not good enough for me. I want you to make one up right now, and we're going to see if it gets disproved. You make one up, give it to me. Not too crazy, though.
1, 1.
Yeah. Get a little crazier.
2, 2.
Are you kidding me? 2, 2? Okay. All right, well, let's do 2, 2 and 1, 1. It's I think that's kind of gutsy, actually.
Well, it's too high.
All right, so we're going to do these. We're going to see if t of u plus v is equal to t of u plus t of v. Now, if it is, then we say it is a linear transformation. Now, the problem with this method is you can't prove it either. You can prove it the other way, but you can disprove it this way. So, when you add these together, u plus v, you're going to get what? What are you going to get?
3, 3.
You're going to get 3, 3. Now when we put this together, Okay, that's u plus v. So what's t of u plus v? What's t of u plus v?
3, 9.
Yeah, it's going to be 3, 9, because we're going to put the x in here and the y there to make that 9. Now let's do them separately. T of u is going to be 2, 4. Does that sound good? And T of v is going to be 1,
1.
1. Okay, so then when you add those together, oh, good. You lose. I mean, you win. It's going to be 3, 5. Is that equal to 3, 9? No. So, therefore, not a linear transformation by counterexample. I can't see that. I don't think I can see this. There it is. Thank you. By counterexample, yeah.
You said that you can't prove something by like substituting in values, but can you like disprove something by the step you didn't take before? Like the actual text, can you disprove it that way?
Yeah, you can do that with a proof method too, yeah. A lot of, yeah, this is one method, correct. But it's kind of slick, I like it. Real quickly then, Kurt, question?
Never mind, actually, because we're a little short on time.
Oh, we are very short on time. Okay, so just real quick, these are 3 properties, and then this is just saying that you can do the linear transformation of the image, and you can do the linear transformation of the vector space. And what this means is that you can break 3 into 3 times, 3 times t of 1, 0 plus 5 times t of 0, 1. And so if you know what this transformation is for 1, 0, and this is for 0, 1, and it is a linear transformation, this is really simple. I'll throw you at that example. So for Monday, I'm going to have you do 2, 4, 7, 8, 9. I'm going to check this homework on Monday. So got the weekend to do this, 2, 4, 7, 8, 9. And I think it'll go well. And then we'll do 2 days next week of new stuff. We'll wrap it up next week. And then on Thursday, review test will be next Friday on this fun stuff.